reverse thrust system and the ignition and starting system, followed by a look at normal start. First, we will discuss the reverse thrust system. The indicators for the reverse thrust system are located on the aft overhead panel and on the center instrument panel. The reverse thrust levers are located on the control stand. There are 5 distinct positions. Reverse thrust is accomplished by left and right translating reverser sleeves on each engine, which allow fan discharge air to be deflected forward. System A hydraulic pressure is used for normal operation of the number 1 engine thrust reverser. Engine number 2 uses hydraulic system B. Hydraulic pressure from the standby system is the alternate pressure source for both reversers. Let's look at the engine number 1 thrust reverser. System A hydraulic pressure is supplied to an isolation valve. The isolation valve is spring-loaded to the closed position. Normal opening of the isolation valve requires battery bus power, and 3 conditions must be satisfied. First, the respective engine fire switch must be down. Second, either the air-ground safety sensor on the right main landing gear must be in the ground position, or either the captain's or first officer's radio altimeter must be sensing less than 10 feet. When these conditions are satisfied and the reverse thrust lever is raised, the isolation valve will open. If hydraulic pressure is available, reverser operation is now possible. Hydraulic pressure passes through the isolation valve to a control valve. The control valve directs hydraulic pressure to deploy or stow the thrust reverser. The reverse thrust lever also controls the position of the control valve and an electromechanical lock installed on each thrust reverser sleeve. When the reverse thrust lever is pulled up, the electromechanical lock releases. The control valve directs hydraulic pressure to deploy the reverser, and the reverser sleeves move aft. Movement of the thrust lever past the interlock position is restricted until the sleeves have approached the deployed position. At that time, the lever may be pulled to detent number 2. When necessary, the reverse thrust lever can be pulled to the maximum thrust position. Lowering the thrust lever past detent number 1 will start the sequence to position the control valve and direct hydraulic pressure to stow the reverser. The reverser sleeves move forward. After the thrust reverser is stowed, the isolation valve closes and the electromechanical lock engages. Thrust reverser position is controlled by the reverse thrust lever and monitored by the reverser unlocked light. When the reverse thrust lever is down, the reverser sleeves are stowed and the reverser unlocked light is extinguished. When the reverse thrust lever is moved to the interlock position, the reverser begins to deploy. The reverser unlocked light illuminates. When the reverser is fully extended, the interlock releases. The reverse thrust levers can then be moved aft for increased reverse thrust. Moving the lever to the full down position directs the reverser to return to the stowed position. When stowed and locked, the reverser unlocked light extinguishes. The reverse thrust lever is locked down whenever the forward thrust lever is not in the idle position. The thrust reverser system contains an auto restow feature. When the reverse thrust lever is lowered to the stowed position and the reverser sleeves are not stowed and locked, the auto restow system will open the isolation valve and direct hydraulic pressure to stow the reverser. In case of either incomplete stowage or uncommanded motion of the reverser sleeves toward the deployed position, the auto restow system will command the reversers to stow. Once the auto restow circuit is activated, the isolation valve remains open and the selector valve is held in the stow position for the remainder of the flight. In addition, the reverser light on the aft overhead panel remains illuminated until the system is reset in the E&E bay. Answer C is correct. The engine number 1 thrust reverser is operated by hydraulic system A. The engine number 2 thrust reverser is operated by hydraulic system B. The reverser light will illuminate when the isolation valve and the selector valve are in disagreement, or the thrust reverser sleeve half positions are in disagreement for more than 2 seconds, or the auto restow circuit has been activated. If the reverser light remains illuminated for more than approximately 12 seconds, the engine annunciator light and the master caution lights will also illuminate. During a normal landing, the reverser lights will illuminate when the thrust reverser system is commanded to stow and extinguishes 10 seconds later when the reverser sleeves are fully stowed and the isolation valve closes. Now let's look at the ignition and starting system. Start valve open lights are located on the center instrument panel. The pneumatic air supply used for the starter can be supplied from one of 3 sources. The source of air can be a pneumatic ground cart, an operating engine, or the APU. The start valve open light is connected to the starter valve. Anytime the starter valve is open, the start valve open light is illuminated and air is being supplied to the starter. Controls for the ignition system are located on the overhead panel and on the control stand. These controls consist of the engine start switches and the start levers. The ignition select switch has 3 positions, allowing for the selection of the left, right, or both igniters. Here, we have selected the left igniter in both engines. Either the left or right igniter should be selected on alternating flights. The ground position of the start switch allows use of the pneumatic starter. Moving the switch to ground closes the engine bleed valve and opens the starter valve. Air is supplied to the starter and the start valve open light illuminates. The ground position of the switch also arms the ignition circuit. Here, the left igniter is selected. Therefore, the left ignition circuit is armed. When the start lever is moved to idle, it completes the high-energy circuit to the igniter. At 46% N2 RPM, the start switch automatically moves to off. The ignition circuit is deactivated, the engine bleed valve returns to the selected position, and the starter valve closes. The start valve open light will extinguish when the starter valve closes. The continuous position provides high-energy ignition to the selected igniters. This position is used to help prevent an engine flameout during takeoff or landing, or during operations in turbulence or icing conditions. The flight position provides high-energy ignition to both igniters, no matter which igniter is selected. The ignition select switch will remain in the selected position. In summary, the engine start switch has 4 positions. The ground position is used for ground starts and, when necessary, starter augmented in-flight starts. It arms the high-energy ignition for starting and engages the pneumatic starter. The continuous position is used for continuous high-energy ignition during takeoff, landing, and prior to turning on the engine anti-ice. The flight position arms the high-energy ignition and is used for restarting an engine in flight and for flight in moderate severe turbulence and icing, and in moderate heavy rain, hail, or sleet. The correct answer is C. Starter cutout occurs at 46% N2 RPM, and the start switch returns to off. Let's now discuss a normal start. Initial steps for an engine start are listed here. Study these steps and start when you are ready to continue. Check the fuel pump switches on. A duct pressure of 30 psi is the minimum required for engine start. Select the left or right igniter. The left and right igniters should be used on alternating flights. The left igniter has been selected for this start attempt. Position the engine start switch to ground. The start valve open light illuminates. With the starter engaged, N2 rotation occurs and the N2 RPM indicator begins to move upscale. As N2 RPM increases from 15 to 20%, the N1 indicator begins to move. An indication of N1 rotation must be observed before the start lever is raised to idle. At 25% N2 RPM, or maximum motoring, and a minimum of 20% N2, position the start lever to idle. This provides ignition and fuel to the engine. Additional steps for an engine start are listed here. Study these steps and start when you are ready to continue. There is an initial indication of fuel flow. The EGT indicator shows a distinct rise in temperature at engine light-off and continues to rise toward the green band as the engine accelerates. Starter cutout occurs at 46% N2 RPM. The engine start switch automatically returns to the off position. An indication of oil pressure must be observed by the time the engine is stabilized at idle. After the engine reaches idle, the instruments stabilize in the green band. There are two cases you should note. Oil pressure in the yellow band is considered adequate for engine operation at idle. Additionally, during cold weather operations, the oil pressure may rise above the green band. Now, review the first part of the engine start sequence and the second part of the start sequence until you are confident you can do it from memory. Refer to the limitations section in the operations manual. Review the limitations associated with engine starting operations. This completes our discussion of power plants.